The Express Rail Link is a major infrastructure project connecting Hong Kong's railway network to the high-speed China system, which will forge new physical and economic links with the mainland. Running from a new terminus in West Kowloon to the Shenzhen border, the project is split into 11 sections. This section, Contract 811A, is a challenging cut-and-cover tunnel immediately north of the proposed West Kowloon terminus. The site is dissected by a number of busy roads and the MTR's existing West Rail Tunnel. Along with the construction of the running tunnels, this contract also includes the construction of the MKV ventilation building. Bachy, Soletanche and Laing have come together in a JV for this project, having worked on many similar projects around the world, bringing an enormous wealth of experience and knowledge. Bachy Soletanche have been operating in Hong Kong since 1973 and is a wholly owned subsidiary of Soletanche Bachy, the world's largest geotechnical contractor. Laing, UK's largest privately owned contractor, have also been associated with Hong Kong for many years, having worked on projects such as the construction of Olympic MTR station, just up the road from the current 811A site. The JV has employed local engineering consultants, BNAIM, to design the ELS system and initiate settlement mitigation measures. Their design of the ELS revolves around the constructability of the permanent works, which features the ability to remove the lower two struts after the pouring of the structural blinding or the base slab. After mobilization, the team will start the construction works on two main fronts, the northern section and the southern section. Work will start in both sections on the construction of the board pile foundations. The Lai Chung Road and associated services will be diverted during the construction and reinstated at the end of the contract. The method of excavation will be by cut and cover. This requires the installation of a diaphragm wall to enclose the site and provide a safe working environment. In the northern section adjacent to the existing CLP substation, the design of the diaphragm wall and strutting, along with grouting to stabilize the ground, will ensure that the building will not be adversely affected by the construction works. In the southern section, the existing concrete bridges T1 and D will be replaced with a temporary steel structure. After the diaphragm and temporary slurry walls are completed and the site dewatered, the main excavation works can commence. The struts, wailings, king posts and bracing of the ELS system are fabricated on-site and installed level by level until the excavation reaches the site formation level below the base slab of the new running tunnels. After a layer of blinding is laid, the construction of the tunnels can commence. The method of construction of the base slab is much the same in both sections. After a waterproofing membrane is laid, the rebar is fixed and tied into the piling where required, and the reinforced concrete base slab poured. In the northern section of the project and up to the interface with the existing WRL tunnel, the removal of the lower two struts allows the concrete running tunnels to be constructed using a tunnel-formed travelling formwork. Whereas in the remainder of the southern section, where the existing Barrettes and WRL tunnel interfaces with the new alignment, the running tunnel will be constructed using separate wall and soffit formwork. After the roof slab of the running tunnels has been completed, the MKV ventilation building, which is the only permanent above-ground structure of this contract, will be constructed. Waterproofing and backfilling works proceed from the south. Once the TBM from the adjoining works has entered the retrieval shaft and been extracted by mobile crane, the final section of tunnel can be constructed and the entire site backfilled, signaling the completion of the contract. One of the main challenges of the project is the complex and confined working space underneath the existing WRL tunnel. The team have, working closely with BNAIM, studied this area and designed the ELS system and the installation of the H-piles to enable the props to be installed with the minimum of site welding. The JV will install a series of flat jacks to allow the controlled load transfer from the existing WRL tunnel to the new foundations via the new tunnel structure. The replacement steel bridges at roads D1 and T will be assembled on site and lifted into place during non-peak hours. This process is repeated until all sections of the bridge are located and the road surface and services are completed. After the traffic is transferred onto the new steel bridge, the existing bridges will be cut into sections on falsework support, lifted off and crushed at ground level before being removed off-site. The erection and demolition methods have been carefully developed to ensure the safety of live traffic within this area. On a project such as this one, there are many logistical challenges which have been considered in developing methods to guarantee a smooth, timely and safe delivery of the works. Here, the JV will adopt all necessary incentives to maintain their outstanding safety record. The Bachy, Soletanche and Laing JV have a strong management team ready to undertake this challenging project that will ensure that all key dates are met and that the risk to the workforce and the community is minimized. Bachy, Soletanche and Laing have the proven track record to partner with the MTRC in delivering this complex and important project on time and within budget.